Example 6. If our derivative here is g of x, or g prime of x, and we want to find g of x, if g of x passes through the point negative 1, 1. So what we're going to do with this problem that was just similar to what example 5 was, is again we're going to start here with the g prime of x, trying to find an original function, but this point right here is going to help us really narrow down. Instead of saying plus c, it's going to help us kind of not have a plus c anymore, but actually find a constant value. Okay. So if g prime of x is going to be basically x to the negative 2 plus 2x, let's see if we can find an original function. Okay, so what would I have to have here so that when I took the derivative, I've got x to the negative 2? What if I try something like if I did 1/2 x, would that work? Not so much, because the derivative would only be 1/2. What if I just tried something like, how about x to the negative 1? So that would be the negative x to the negative 2. Ooh, and we're almost there. We just need it to be positive instead. So what if I already had a negative out front? Okay, so then right there, if I drop the negative 1 down front, a negative times a negative would be positive, and then subtract 1 from our exponent would give us a negative 2. Okay, doing the same thing over here with our plus 2x. Okay, what I would have to do is then obviously maybe x squared. Hopefully that's a little more obvious. So drop the 2 down and then subtract 1 would give you then just 2x. And like before, we would normally right there stop and say plus c. Okay, so that's a function that would represent any derivative or any function g of x, all the possibilities that would have this guy as its derivative. But now we're going to narrow it down. We have a point where the x value is negative 1, the y value is positive 1. So let's come in here. 1 is equal to a negative 1 to the negative 1 power plus negative 1 squared, and then plus c. So now we can actually find c. Okay, so finish solving this out. You'll get 1 is equal to, obviously 1 to any power is still 1. But since that power is negative, it's going to keep it negative 1. So this is a negative 1, which is 1, plus 1, plus c. Okay, so 1 is equal to 2 plus c, or c is equal to negative 1. So combining that information with the regular function that we just saw, we can say then that g of x, specifically for the point negative 1, 1, is going to be negative x to the negative 1 plus x squared minus 1. And there's the answer for that problem. Okay, example 7. Given the velocity v equals 32t minus 2 and the initial position, find the position of the object at time t. So we have a special note here that v equals ds dt. In this problem, we're going to be doing just what we did in the last problem. Okay, it's all about really this note right here. Okay, because we have v, which is actually equal to ds dt, is 32t minus 2. So what we have is we have the derivative. We want to first of all find the actual, we have velocity, so we want to find the main position, okay? And we want to go back to find the original equation. I don't want ds dt, I just want s. Okay, so what would I have to take the derivative of to get this right here? Well, obviously it's going to be something like a minus 2t. This part right there tells me my variable is t, and also the fact we have one right there. And right here, if I wrote this as 16t squared, would you all agree that 2 times 16 is 32? And I subtract 1 would give me that exponent of 1. And then we have the plus c. Well, we don't want plus c. We want actually to find out values of it. So if I go to the information they gave us, they tell us that t equals 0.5 and then s is equal to 4. So plugging this in, I'll get 4 is equal to 16 times 0.5 squared minus 2 times 0.5 plus c. So solving this out real quick, we'll get a value of c equals, so this is 4, this all comes together, give you 3, so c equals 1. Okay, so combining that together with the function that we just saw, then s is equal to 16t squared minus 2t plus 1. And then what we did is then we found this right here will find the position of any object at time t. All we have to do is plug in, like, let's say t equals 1 second, and they'll give us position. Okay, last problem. We have the acceleration, a equals 9.8, the initial velocity v of 0 equals -3, and the initial position s of 0 equals 0, and we want to find the position of the object at time t. Okay, here's all about those two notes one more time. We are basically going to find a function that by the time I take the derivative twice, that's what we're looking for, okay? So let's start out basically what's given to us. We know that a is equal to d squared s, whoops, not ds, but d squared s over dt squared, okay? And all that equals 9.8. So now let's just take it down one. What would I have to take the first derivative of? So ds dt, so that I got 9.8. Well, obviously that would be 9.8t, right? So if I started right there and I took the derivative, I would just get the coefficient, which is 9.8. But always we got to add plus c. So we're going to take 2 seconds, stop right there, give us some information, because what they have given us is this. We're going to pull the first information. The second derivative is acceleration, the first derivative is velocity, and then the regular function is just the position. So it goes position, first derivative tells us velocity, second derivative tells us acceleration. That's why I know to look to this one. So I'm dealing with the first derivative and I need the velocity, I need v. Okay. So right here, then we're going to get -3 is equal to 9.8 times 0 plus c. So c is equal to -3. So starting out then for the second part, and so we can kind of finish this up then, we know that then ds dt is equal to 9.8t minus 3. All right, let's finish solving this out then. What would I have to take the derivative of to get this? So obviously s is equal to, okay, so what's the derivative that would give me a 9.8t? Well, what's half of 9.8? How about 4.9 t squared? And then here would just be minus 3t. So right there, if I drop the 2 down front, 4.9 times 2 is 9.8. The bt to the first, and then minus 3t plus c. Okay? And then we're going to go to our last little point to get the rest of it. So 0 is equal to 4.9 times 0 squared minus 3 times 0 plus c. So that's telling us that c is equal to 0. All right, so to wrap this up and give us one grand equation, then we have the grand equation of s is equal to 4.9t squared minus 3t, and then I'm going to go ahead and put plus 0 just for emphasis since we took the time to actually find that. And there's the overall equation that by the time I took the first derivative and the second derivative, I would just get 9.8, but it would give me a position value of 0 at 0 and a velocity value of 0 at -3.